People react to the weather in different ways. Some may be stunned by the beauty of a winter snowscape. Others may get angry at the thunderstorm that ruined their vacation. And most of us will stand in awe at the fury of its full power. But just about everyone is interested in the weather, and people have long searched for signs in nature to predict what the weather would be. A long time ago, someone noticed that crickets are very sensitive to changes in the weather. Noisy crickets that suddenly get very quiet can be a sign that a storm is on the way. In some parts of the world, a red sky at sunset was called a sailor's delight, because it was a sign that good weather would soon arrive. Today we look for our signs in the air around us, for we define the weather as the state of the air at any time. How warm or cold it is, how wet or dry, how clear or cloudy, and how calm or windy. There's still a lot about the weather we don't understand. We do know that we must recognize what happens when warm and cold air meet in their daily battles across the Earth. For great changes in the weather often occur at places where warm and cold air meet. We know that the land and water of the Earth's surface play an important role in making the weather. Physical features on the Earth's surface can affect the state of the air in ways that are difficult to predict. We also know that weather is a product of the Earth's atmosphere. The atmosphere is a blanket of gases and dust that surrounds the entire Earth. Its slight blue color gives the impression that the atmosphere is thin, like the skin of an apple. Yet it protects us from the sun's rays, or radiation, and keeps the Earth from getting too hot or cold. Our atmosphere is to us what water is to a fish. Fish are surrounded by water, but are not affected by small movements within their watery environment. They seem to take note only when there is a major disruption. The same is true of us and our atmosphere. We seldom notice that it's constantly moving and is torn daily by battles between warm and cold air, battles that are fueled by the sun. The sun. For us, it's the most important source of energy in the solar system. This great furnace throws out an endless fountain of radiation that reaches the Earth every minute of every day. Most of the radiation that reaches the Earth is reflected back into space. The rest is absorbed by the land and water on the planet. The Earth's surface soaks up the radiation and then converts it into heat. But the sun's radiation doesn't strike the Earth evenly across the planet. To see why, compare the radiation striking the Earth near the equator with that striking near the North Pole. Near the equator, the radiation is very concentrated. But near the North Pole, the same amount of radiation is spread out over a much wider area. Areas near the North and South Poles don't get much radiation, so they remain very cold. This might seem strange because we know that the polar regions get sunlight 24 hours a day during certain times of the year. But they don't get enough radiation to keep the air warm. Areas near the equator get a lot of radiation, so they get very warm. We say that the Earth is being heated unequally, and this is important to the weather because it creates great bodies of warm and cold air called air masses. We can see how this happens by observing that the equatorial regions get so much radiation that there is an excess of warm air that builds up and overflows. Polar regions have an excess of cold air, so much that it too overflows. The excess warm and cold air grows into great masses that flow away from the equator and away from the poles. They meet in the temperate regions, which are often the site of some of the most changeable and violent weather on the Earth. Weather extremes are common in the temperate regions because these are the places where warm and cold air most often come together to do battle. We can get an idea of what happens when warm and cold air masses come together by imagining that this hot air balloon is a warm air mass and watching what happens when it runs into warmer and cooler air. If the temperature of the surrounding air is about the same as the warm air mass, then the warm air mass will move slowly and stay near the ground. If the warm air mass moves into a cooler area, then it will rise because it's lighter than the surrounding air. If it passes out of the cool air into some very warm air, it will fall. Finally, if the warm air mass is not moving and some very cold air sweeps in, it will rise very fast. By watching the balloon, we can see that warm and cold air masses don't mix, and whenever they get together, something has to give. Some of the most important weather changes we have take place where a warm air mass meets a cold air mass. The meeting place of a warm and cold air mass is called a front, and like a front in any battle, it's where most of the action takes place. If the air masses are not trying to force each other out of the way, the front is called a stationary front. You can think of the battle as a standoff. In this side view, we can see another type of front. Here, the warm air mass overpowers the cold air mass and forces it out of the way. It's called a warm front because the warm air is the winner. If a cold air mass forces warm air out of the way, the front is called a cold front. We can see that as the cold air rushes in, the warm air is thrust up and over the top of the invading cold air. This uprush of warm air is what often makes the cold front the site of violent weather. For as the warm air rises up higher and higher, something important happens to it. Water leaves the warm air. When condensed onto tiny particles of dust, this water becomes a cloud. Along a cold front, cottony puffs called cumulus clouds grow together and become the dark, threatening giants known as thunderheads. These clouds are loaded with moisture. They also bring lightning and ear-shattering thunder, but there's often an uneasy stillness in the air just before the storm strikes. Thunderstorms may form in a line all along the front for hundreds of miles, bringing heavy winds, rain, or hail, and too often the most dangerous of all storms, the tornado. If all we had to worry about was the movement of air masses, weather prediction would be pretty easy. Unfortunately, the story of weather is not this simple. One of the most important ingredients of weather is the makeup of the Earth's surface. Physical features such as hills and valleys can disturb the course of the wind and make the weather difficult to predict. Lakes and other bodies of water have important effects on the weather because water is very stubborn about changing temperature. If it's cool, the water and the air around it tend to stay cool. We can get an idea of why water is so important to the weather by looking at what might happen to this town, which is located only a few kilometers from this lake, on what could have been a lovely day. The weather forecaster has predicted clear skies with temperatures in the 90s. The people in town get an early start. Some go shopping, and the lucky ones head for the lake. In town, the sun's radiation beats down on the buildings, streets, and sidewalks. These objects change a lot of the radiation into heat, and before long, it's very hot. The lake remains cool because more radiation is needed to change the temperature of the water. In the early afternoon, the cool lake air begins to rush inland. The cool air forces the warm air up. Cumulus clouds begin to form, then grow together over the town. Very soon they're dark and heavy with moisture, ready for a good hard burst of rain. While the people in town are getting drenched, at the lake it's still a very nice day. Some people blame the local weather forecaster, but changes in the weather brought about by small differences in the Earth's surface are the hardest to predict. At this weather station, meteorologists, people who study the weather, make predictions based on some of the signs we've seen. They keep an eye on the wind, where it's coming from, and how fast it's going. They keep track of the temperature of the air and determine how likely it is to give up its moisture. If it rains or snows, they determine how much occurred and when it happened. They watch the movement of clouds, air masses, and fronts, often with the help of satellites that provide excellent photographs of what's happening high above the Earth's surface, like this developing hurricane. By watching for changes in these and other signs, they're able to predict with great accuracy what will happen along a major weather system, like a cold front, that affects a large portion of the Earth. But physical features can have important effects on what happens within a very small area. So, if the local weather forecaster predicts a 40% chance of rain, it wouldn't be a bad idea to get a second opinion.